what they don't tell you when you buy that is those things have to be touching each other and they magnetically connect. So people are returning them because of that, because they say, well, you might as well just plug it in. So what I wanted to show you was sort of how you could use this technology that we're doing with WiTricity, where you could break that distance barrier. Because remember, well, actually that mat is not unlike a transformer. It's got two coils in it. They have to be next to each other. If they're not next to each other, it won't work, unless you can get them to resonate at the right frequency. So one of the cell phone companies came to us and they said, you know, we like the idea of a mat. We don't like the fact that it has to be perfectly aligned and you have to be able to do it anywhere. So we made one. It's got electronics and a coil, if you want to think of it that way. It's got a regular, you know, plug here that I'll just plug in. And let's see here now. Will I be able to do this? So let me see if I can do this here. So let's pretend this is the mat. Now here's a cell phone. We put it in the back of the cell phone. So the coil and the electronics are all in this Google G1. When you hold it up here, see how the light comes on, the phone comes on. By the way, what's really cool about this is it doesn't matter where you put it. As a matter of fact, it doesn't even matter where you put it this way. Until you get up to about here, you'll see the light go out right about there. So it worked almost 1.5 feet away. And it works through materials. And I get asked this question. I was showing it actually to a gentleman before. You know, it goes through people too, right? So if I held this thing up to my back and just sort of held it up, I'm charging the phone through my body completely safely. This meets Part 15B, those of you that are into this stuff. This meets all of the federal regulations. Now, that's a recharging application, which is hard to be that environmental because I think we could probably, I couldn't do without my phone, but let's think about things that you could do, potentially. One of the ones we're working on is solving the honey-do list problem. So, you know, honey, will you do this? Honey, will you do that? One of them is, would you put the under-cabinet lighting up? So they, you know, some of the lighting companies with LED lighting, which is very efficient, you know, they put an LED and they put 3 alkaline batteries in this thing, and then you have to stick them all up there, which gets you off the list, but you know what? The batteries die pretty quickly. And if you have more than one, you have to turn them on and off. Simultaneously, you know, each one has to be turned on and off. So imagine if you could, you can just do that wirelessly. So we put in here, we can remove the batteries, and it allows you to do that. We'll go back to my wireless mouse, right? There's no battery, there's the coil structure, we pulled the batteries out, it's got the WiTricity semiconductor devices in it, and you'd see that it works there very easily. And same thing with the keyboard, I'll show you that in a second. This one will be a little bit harder to see, but there are no batteries in this keyboard, we pulled them out. I'm not picking on the company that makes it, we just pulled it out, we stuck the resonator in, stuck the chip in there. But one of the things about this technology, which is quite unique with highly coupled magnetic resonance, is it'll hop. It's a distance-based phenomena that's largely based on the surface areas of these coils. So the further apart you pull it, see how it'll stop working. So one way of extending the range is you can actually hop to devices that have no inherent energy source. So here's a desk counter. We put a coil on the back. It doesn't take up any thickness. It's less than 1 millimeter thick. It's got a chip on it, but no power source. So what will happen, because it's an area-based phenomenon, that when I take this, you'll see that the light goes on, and it's not getting its energy from here. It's getting its energy because it hopped to here and hopped to here. Which means, by the way, and by the way, it works like this as well. You see the light still on. Your phone will charge pretty much anywhere on your desktop because it's getting the energy from the desk calendar, which has no inherent energy source. And in fact, if you want, you can place, this is probably a little hard to see here, but the keyboard's actually on now. So the keyboard's being powered. You can do this with your mouse, as I showed you already. Probably have to put it up about like that. So the mouse is on, your phone charges, and you can have your lighting as well. So it's got a lot of really good applications at getting rid of these alkaline batteries. And then I finally wanted to just take you quickly to the car charger. They wouldn't let us bring an electric vehicle in here, so that's problem number one. Problem number two is 3.3 kilowatts will blow a circuit breaker at 115 volts, those of you that sort of know that. So what I did was brought that system that was underneath the car, or a system like it. So that's the one that you'd see sort of underneath, be sitting in a mat, or it could be underneath the concrete. And that's the one that's underneath the vehicle. And what we've got here is a power supply, which those of you that are engineers, you can multiply those two numbers and you'll see the input wattage, because it'll be volts times amps. And I'm going to keep it under a kilowatt because I do not want to blow the breaker and put us all into darkness here. But you'll see it outputs into an amplifier, which puts it at high frequency, which goes into the mat. And then what I did was just plugged it into 1,000 watts of Home Depot lights that I bought for 29 bucks in Home Depot, which is a good way to sort of look at it. And what will happen is, and that way you can sort of see the efficiency without having to measure it. So what I'm going to do now is just turn the power on. And what you'll see is, it's about 900 watts, and you're looking at a 1,000-watt light bulb. So it turns out, when you actually run the calculation, at that distance, at that ground clearance distance, you're looking at something that's well over 90% efficient. It's an absolutely amazing phenomenon, so I sort of get why the guy that started our company won the MacArthur Fellowship. So anyway, that's hopefully quick, efficient, and thank you.
Questions?